All right, let's begin part 2 of our final lesson here. And that is really solving problems involving sinusoidal functions. So now we're going to get word problems for the most part, besides this first example. Okay, we're going to get word problems that just look like this. We are going to have to draw a sketch of what's happening and then determine the equation that would fit our sketch or this word problem. All right. So in the previous lesson, we were given the graphs. Now we're not going to be given the graphs. Okay. So let's begin with an example here. In this example, we're just kind of getting warmed up. It just kind of takes us through a real example of weather and the month that you're currently in here, the city of Hamilton. All right, so we've got the month all the way up from 1 to 12. So obviously we have January to December, and we have the temperature below, okay, the average temperature, okay, or it's represented by the day in the middle of the month. Okay, the average temperature is represented by the day in the middle of the month. So all these temperatures are in the middle of the month, okay? So we need to plot the temperature for Hamilton and fit a sinusoidal curve to the points. So if you were to graph this, month would certainly be on your x-axis, and temperature, which is the dependent variable, would be on your y-axis, right? Because the temperature depends on the month. So this is independent, and this is your dependent variable. The next thing I would look at is, okay, I need to figure out a scale. So clearly my scale here is simple enough. I just need to go from 1 to 12, go by ones. But from here on my y-axis, I have a minimum temperature of -5 or -5 and a maximum of 22. So I just need to make sure that I'm going from -5 degrees Celsius to 22. So determine a scale in order to do that. And going by threes works, okay? But you have to show part of it on the negative side, right? So -3, -6, and then 3, 6, 9, and so on and so on. Now, I wanted to make it a little bit neater, so I did it in Desmos. Okay. So if we go into Desmos, you will see my curve here. And I am going to take a little screenshot so I can write on that. Okay. Now let's take a look here. Okay, so I'm just going to write here, and I'm going to plot a sinusoidal curve that matches this. Okay, a sinusoidal curve that matches this. So something along these lines. Now, it's not going to be perfect. Okay, so it's a curve of best fit. Curve of best fit, but you can see it follows a sinusoidal model, and that makes sense because each year the temperature is fairly cyclical, even though it's not exactly the same each day compared to the previous years. It'd probably be pretty close besides some outliers, right? And if you were to take the average, it would actually be very, very close, probably easily within 1 degree. Okay, so here's our sinusoidal curve. From here, we could figure out an equation if we wanted to. We could figure out our A value, our amplitude. We could figure out our C value, which is the equation of axis. Okay, we could figure all that out if we take this is our max and this is our min, right? So 22 is our max and -5 or -5 is our min. We could find C, we could find A. We'd certainly already know that one period is going to be 12 months, right? Before everything repeats again. So one period will certainly be 12 months. So we could figure out an equation here pretty easily, okay? Pretty easily. But the question doesn't ask us to do that, okay? So the question doesn't say anything about that. What it does say is estimate the average daily temperature in Hamilton on the 200th day of the year. We got a problem here, okay? What's given to us is in months, not in days. So what I suggest you do, okay, is convert your 200th day, convert that into months. Now, how do we do that? Set up proportions. If we know that 1 month represents how many days on average? Besides February, every month has either 30 or 31 days. So let's say that the average number of days in a month is 30.5, in between 30 and 31. I mean, we know February has 28, but let's go with 30.5. Well, I want to figure out how many months 200 days is. So notice I line up my months in the numerators, my days in the denominators. Cross multiply. Divide 200 by 30.5 and you get 6.6. So estimate the average daily temperature in Hamilton on the 200th day. Well, we can use our graph to do that. Okay, so it says to estimate. We can use our graph. Now, if I were to go to my graph again, and I didn't save my picture, so my picture's gone. But if this is 7, let me take another screenshot actually, really fast. Okay, so here is the 7th month. 6.6 is probably somewhere here. So draw your curve. Oops. Draw your curve. Your curve of best fit as best as you can, okay? And go up from 6.6 as best as you can here. Cut across. And what do you expect that temperature to be? Okay, well, I'd say probably about 21.5. Right? Let's just say 21, maybe 20, it's pretty close to 22 degrees. But let's say 20, and we expect that. It's in June. The 6th month is in June, right? But it's 6.5 months. It's just over 6.5. So it's almost July. So expect the average daily temperature to be pretty close to July. So 21.5. So if I go back in here, oh, by the way, I should write months there. Okay. So from the graph, right? From the graph, the average temperature is approximately 21.5 degrees Celsius on day 200. Okay? So we converted to months because my graph was in months, right? So we found out how many months 200 days was. It was about 6.5 months. Okay, and we were able to answer that question. Now, we didn't have to find an equation there, but if we did have an equation, we would sub in 6.6 for x. So if I did have an equation, I could answer it probably a little bit more precisely if I were to sub in 6.6 for x. That's more precise than just using your graph. Okay? Now, let's continue. Now we don't have a sketch here. We are going to have to figure it out. So the top of a flagpole sways back and forth, okay, in high winds. So if you ever notice the flagpole, it certainly sways back and forth, okay? That's obvious to see. The sway is 10 centimeters to the right, so that's positive 10, and 10 centimeters to the left of its resting position. So it continuously does this repetitive motion of going a maximum of 10 centimeters to the right and a maximum of 10 centimeters to the left. And let's assume that it's consistent. It moves back and forth 40 times every minute. That's important. That's going to help us find our period. So if it's moving back and forth 40 times every minute, remember what 1 period is. We want to find how many times it does it, okay, how long it takes to do just one time. So if we have 40 times in 60 seconds or 1 minute, how fast does it do it for just one time, right? That's what we need to find in order to find our period. And you know what? I'm going to do that right now. Okay, I'm going to do that right now. So if we have, okay, if we have 40 cycles in 60 seconds or 1 minute, okay, how many cycles, so X, or sorry, we want to find one cycle, and we want to know how much time it does to do that. That's what's going to give us our period, the time for one cycle. So if we know that it does 40 cycles in a minute or 60 seconds, we want to find out for one cycle, how fast can this happen here? So we have 40x is equal to 60. X equals 60 divided by 40, which is every 1.5 seconds, you have one full cycle. That's a nice number. So you need to recognize that they're giving you information for the period here, right? 40 times every minute. That's 40 cycles every minute. But we need to find out just one cycle for the period. And so we set up a proportion. I told you these proportions will come in handy, and you can see that they're showing up every single unit, right? Okay. At t equals 0, so if I were to draw a sketch, at t equals 0, so if this is time and this is my sway, okay, I know that I'm swaying from positive 10 to negative 10. They told me that. Okay? So I'm just tracking the sway here, and it's going to be repetitive motion. It's going to sway one way, come back the other, and keep repeating. At t equals 0, the pole was momentarily at its resting position. So this is actually starting right on the equation of axis. It's at its resting position of 0. That's its normal resting position without any sway. Then it started moving to the right. So they told us that the right was our positive 10. So it starts going, on my graph, it's going to go up. Okay, so it's going to go up from that point. Determine an equation to describe the distance of the top of the pole from its resting position in terms of time. Okay, so let's do one period. Okay, let's do one period. Let's show one period here, 1.5 seconds. That means, let's think of what's happening here. It's going to go up, and I should erase this here. It's going to go up. It's going to cross or go back to that resting position momentarily before it starts to sway to the other side. Okay, and about halfway here, it's going to come back and go right there, back to its resting position. So it's going to reach a maximum. Okay, let's say here, if this is 1.5 for one full cycle, 1.5 divided by 2 is 0.75. So this would be 0.75 there. Okay, right there. Divide that by 2, and that's when it reaches its maximum. Okay, and it reaches its minimum right in between 0.75 seconds and 1.5 seconds. Okay, so I was able to draw a sketch simply by the information given to me, that it started at its resting position. One period was 1.5 seconds, right? So I'm only going to draw one cycle here. I know that this is going to happen again here after one full period. And halfway through, it's going to cross my x-axis again onto the negative half. Okay? This takes practice to be able to draw this sketch. No question about it. That takes major practice. What I suggest you do is you cover my answer, you read the question, and try it yourself over and over again until you get it. Okay? Now, it says that we have to find an equation. Okay, so let's find A. my y max is 10, minus my y min, which is negative 10, and divide by 2. So A equals 10 plus 10. Remember, minus and a negative together is going to become plus. So 10 plus 10 divided by 2, well, that's just going to be 10. So my A is 10. My C is going to be y max plus y min divided by 2, which is 10 plus 10. Sorry, 10 plus negative 10. Be careful there. Right, my min is negative 10 divided by 2. This is going to be 0. Your C is going to be 0. Okay? Now, and that makes sense. I mean, you can see that the equation of axis is right through the x-axis there. It's 0. Your period, remember, is 1.5, which means you can find K if you do 360 divided by your period. Okay? 360 divided by your period. So 360 divided by 1.5, 240. So what's happening here is this is a horizontal compression by a factor of 1 over 240. So it's really, really compressed, this graph, right? Okay, we found A, C, and K. Let's determine which equation we want to use. We want to use sine or cos. Well, it's starting on the y-axis. It's starting at the EOA. So the easiest thing to use is your positive sine curve, right? Positive sine curve is the easiest thing there because it's starting at the exact same point, right? You could use a positive cos curve, but then you'd have to have phase shift, right? So if we can do this without phase shift, let's do it. So if we've got A sine, oops, geez. Okay, sub in your A, sub in your K, with no phase shift, so don't have a D value, and then plus 0, so I, of course, don't need to show that. There is your equation. You don't have to do that equation. You could have chosen a cosine curve, but you would have a phase shift of this much. Okay, so right there, you would have that much phase shift. So whatever 0.75 divided by 2 is, which is 0.375, you would have x minus 0.375 in the bracket here. Okay, because the original function would have moved to the right 0.375, which means minus in your equation. Okay? All right. Let's do one more question where we're going to have to draw, again, a sketch. So a group of friends, a group of students is tracking a friend, John, who is riding a Ferris wheel. They know that John reaches the max height of 11 meters at 10 seconds, and then a min height of 1 meter at 55 seconds. So we're going to draw something out here. They said that the max is 11, and the min, and actually, let's not draw it like this. Let's draw my x-axis down lower. So there's my 1, and there's my 11. So this is my height, right, in meters. This is my time in seconds. So after 10 seconds have gone by, so let's say right there, after 10 seconds have gone by, John is at the top of the Ferris wheel. He's at 11 meters. Okay, and then a minimum height of 1 meter at 55 seconds. So 55 seconds, that's going to be way out here. Right down there. Okay, so all we have here is half of a cycle, half of my curve. So if I were to draw this, it would look something like this. That's only half. That's only going from maximum to minimum, right? I know that this curve continues and does this, but they've only given me information for half the curve. And that's okay. That's enough for me to do this here, okay? Let's start by finding the period. Well, the period, if I know that this section here from maximum to minimum is 55 minus 10, which is 45 seconds, right? 45 seconds to go from the top of the Ferris wheel to the bottom. How long, therefore, to go all the way around the Ferris wheel? So if we know from the top to the bottom it takes 45 seconds, how about all the way around? Well, your period is actually 45 seconds times 2. Double it. So if it's 45 seconds halfway through, you've got to double it to get the full period. So 90 seconds is our period here. Okay, 90 seconds is our period. Let's find K since we're already here. K equals 4. Okay, so this graph will be horizontally compressed by a factor of 1 over 4. Okay, now let's find our A value, which is our Y max minus our Y min divided by 2. Our maximum is 11 minus our minimum of 1. Our amplitude is 5 meters. Our C value is Y max plus Y min divided by 2, okay, which is 11 plus 1 divided by 2, which is 6. So at 6, we are halfway. It is our center line through 6. Okay, then we go 5 up, we're at the max, 5 down, we're at the min. Well, we almost have enough to write our equation here. We have A, K, and C. Well, now we need to determine, do we want to use a sine or a cosine function? Either way, we're going to have phase shift here because this isn't going to reach the equation of axis here clearly, right? It's clearly not going to reach there. I can't assume that this is just going to start there. What I know for sure is that if I use a cosine function starting at the maximum, that the original would have shifted 10 units to the right. 10 units, the original cosine function, the base function of y equals cos x, would have shifted 10 units to the right. Okay, so d is equal to 10 seconds right. In my equation, that's going to look like minus 10. So I'm going to write this out as a cosine function because I want to start it at the maximum. And I'm going to fill in all these values now that I found. Okay, so y equals a, which is 5. K is 4. X minus 10. And then plus 6. So let's recap there. That was a tough one because we were only given half the information. To figure out the period, we had to take the horizontal distance from max to min and then multiply it by 2. Okay, that gave us the period, which then helped us find K. From there, we were able to find, because we knew our max and min, we were able to find our A and our C pretty easily. Then, to find our actual equation, we decided to use a cosine curve that starts at the maximum. And we know that the original cosine curve would start right at the y-axis there. And so it shifted 10 seconds to the right. Okay? And so there you have it. We have a cosine curve with a phase shift of 10 seconds to the right. And then with our A, K, and C values installed. You don't have to use, you certainly don't have to use a cosine curve, you could do a sine curve. You know that a sine curve, well, this would end up being a negative sine curve if you had this much phase shift, okay, because it's starting going down on the bottom. So it would be a negative sine curve. Certainly, I think we chose the easiest situation to do a positive cosine curve with a phase shift of 10. Okay, what will John's height be at 78 seconds? No problem now. We can sub x equals 78. Okay, now be careful here. Make sure that you punch this all correctly into your calculator, right? So let's figure out our bracket first. Let's follow BenMass. We've got 78 minus 10, which is 68 times 4, right? 68 times 4. So 68 times 4 is your 272. So we're going to find the cos of 272. Okay, so first find the don't do 5 times anything yet. First do cos 272. So cos 272 is equal to 0.0348, and it's a big decimal. All right, but let's actually multiply it by 5 here. So we have cos 72. Okay, cos 72, multiply it, 272, multiply it by 5, okay, and then add 6. And you should get 6.17 meters. So at 78 seconds, their friend John should be 6.17 meters above the ground. That's what this is saying. Okay, that's what this is saying. So 78 seconds will be somewhere like over here that's outside of my graph, but he should be right around the center, 6.17 meters, right around the center of the Ferris wheel at that point. Okay, there you have it. That concludes this lesson. There's a lot of good word problems to practice on, and we couldn't cover everything in this lesson. There's going to be some new things when we take up the homework and everything, some new things that you're going to learn along the way. But this certainly covers the gist of it on how to draw a sketch of the function and figure out your equation.